Welcome to the Tech Space, and in this tutorial, or this set of tutorials, we're going to be going over C++ in its basic sense, from all of the syntax, the functions, classes, variables, inheritance, just basically learning how to use C++. And C++, as you know, is an object-oriented programming language, so what we're going to need for that is something that can run our code. And there are two basic programs for that. Basically, we have code blocks right here. This is a program that I built earlier. Code blocks is really good. Basically, what you want to do to download code blocks and use it for your C++ is go to codeblocks.org, and you're going to want to go to downloads, and make sure you do this exactly how I'm showing you, or you might have a few problems. So go to downloads, then go to download the binary release, then you go down to Windows if you have a Windows XP through Windows 10, or if you have Linux you can download it down there. But for Windows computers, you're going to want to download the mingdb/setup.exe. So make sure you have 16.01 or higher if you are watching this later. There might be a newer version out, but it has to have the mingw-setup.exe, and then go to sourceforge.net or FossHub, whichever one, and just click direct link. Let this load, and of course just go ahead, click on it, it'll run through all the processes for you, and here's your CodeBlocks IDE. So basically when you get to CodeBlocks, what you'll see is this. See you in the next tutorials as we go over C++ and what it entails. So if you're interested, you can go through these tutorials. If you have basic knowledge of C++ and there's just a few things you want to brush up on, you can just go ahead and click the tutorials that you need. But other than that, we'll be going through all of C++. Stay tuned, subscribe, and I look forward to seeing you in the next videos. Oh, and also, if you have any questions, post them in the comment section below of any video, and I will always answer your questions. I always go through my comments, and I always respond, no matter what the question is. As long as it's not, something rude or anything, I will respond to you. Just leave a question in the comment section. Also, other users can see that who have that same problem or had that same problem, and they can help you fix that problem as well. But other than that, if this is the first time that you've been to the Tech Space, welcome to the Tech Space, and I look forward to seeing you in the next videos. So, see you next time.
Okay, so if you've used CodeBlocks before, you already know how to use it. You don't need to watch this video. You can go ahead and skip to tutorial number 3. But if you don't know how to use it, basically this is how it works. For what we're going to be doing is creating C++ programs. This is just the environment that will build and run the programs for you. Now you may see all this stuff, but we're not going to be using anything but a few of the buttons. This button right here is run. It runs the program for you, and obviously we don't have the program up right now. But this is the run button, and again, if you know this, you can go ahead and skip the video. This is the build and run. So we build the program in the compiler down here to check and see if there are any errors, and it will show you the log after it runs the program if there are any errors, or if there are any major errors, it won't run the program at all. You'll have to fix it before the program runs. So we can rebuild, which is basically just refreshing our build, and it resends it to the build compiler, and the compiler again just rechecks it for errors. And basically these buttons right here are the only buttons that we're going to be using. And again, the new file, open file, save all files, those buttons. So this toolbar you can pretty much forget about. You can take it out if you want. This toolbar you can pretty much, you can forget about this one and this one right here. We're not going to need those. But you can leave them there, whatever, it doesn't really matter. So we're going to go to create a new project, and we're going to go to console applications. So the rest of this, again, is not for C++, or we're not going to be dealing with in this tutorial, because it's way more advanced than just learning the basic programming language for C++. So it's something you do once you know how to program in this language comfortably. So once you learn how to do this, we'll go through all the rest of this stuff. But for now, just go to console application, go to C++, click next, project title, and just give your project a title. I'll just put practice. Click next, and make sure you have the GNU GCC compiler clicked on. Make sure you have create debug configuration also check marked, and release configuration. You can check mark that, or you can uncheck it. I just use it uncheck it for right now. It's really not that big a deal. We're not going to be using anything that requires this, and even an explanation of that really isn't needed for right now. So click finish, and here's your first program. So it automatically builds this program for you, and we'll go over it in the next tutorial more in depth. But basically what this does is it just prints out hello world, the words inside here, to the screen. And if we go up here to build and run, you can see that we get the program hello world. And actually I'll show you under that, it shows you process return 0 execution time, and that's just how long it takes for the program, or how long it took for the program to run. And then once you finish this program, it'll say process terminated within how much time that the program was up for. So that's just two little hints into getting used to C++, and that's basically it. So in the next tutorial, we'll go over the build of C++, its basic layout and stuff like that, and I'll see you there. Welcome back to TechSpace, and in this tutorial, this third tutorial, we're going to be going over how to actually print out your own information to the screen. So first we're going to go over the basic layout of C++. So basically you have this file, or this string of text right here that says number sign include IOStream. And basically what IOStream is a library, which you basically just need to know is required for all C++ programs to run in this platform, and you're going to want to keep it here every time, no matter what program that you're building, no matter what you're doing with C++, you're going to want to keep that there. So next we have using namespace std, just tells the compiler that we're using the namespace std to compile our program, which again just has something to do with the syntax or the library of the programming, or the C++ programming. So you're not going to want to ever take this out. So use these two things in every program that you have. So this is very important. Next we have int main. So basically what int means is it's the start of a function. And in every function we're going to have some type of value. And we'll go over those values later, but for now, this basic function starts with the value int, which stands for integer, and its name is main. In the main function, after that, you have these two parentheses, and those are parameters, and we're not going to use any parameters in our main function right now, as you'll rarely use parameters in your main function. But once you go down into the next part, we have these curly braces, which surround return 0 and a semicolon. So return 0 basically just tells the compiler that we're done running our program. You can take that out. We don't need that anymore in C++. So take that out, click save, and basically we just have the curly braces. And basically inside these curly braces, inside int main, we're going to have all the information that our program will need. So we can, as we go further into C++, we'll find that you can make other functions. But for right now, this is the only function, and this throughout all of C++ is the main function that is used to call other functions into the program. So while that might not make sense right now, later on down the line it will start to make sense and be clear on how that's done. So you can either keep the curly braces right here or put it like this. This sort of makes it more of an element and easier to locate. I like to keep it like this. And basically what we're going to do to print something out on the screen is print C out, and then we're going to go less than, and that's basically saying outward. So you can think of pushing something out to the PC, and then we're going to need curly braces because we're doing text, and then we're going to need two more less thans and an end line to end that line. So this tells the computer or the compiler that we're ending that line of text. So we're going to output something inside here. We can write anything we want, and after that we want that line to end. So if I wanted to enter another line of text, that line of text will begin on a new line. So as we can go in here and type, this is my first program, I can then just copy that, paste it again, and have that on the second line. So first we'll go over the first one, this one line of code, output it to the screen. We're going to build and run it, and you can see this is my first program. Now if I went and pasted that and then said this is my second line of code, so I can say this is my second line of code, print and build that, and of course it ended that line. As you can see, it C out, then we print out this to the program, and then we ended that line, and then we started a new C out, or a new output that started on a new line. So we can go ahead and close that, and that's how you output stuff to the screen using C++. In my next video, we're going to be going over how to use variables. So variables are very important, and it's something that you are necessarily going to need in every single program. Every single language uses variables, and it's very important. So I'll see you in the next video, and as always, like and subscribe and share the video if you found it helpful. But other than that, I'll see you in the next video. Have a good day. Welcome back to TechSpace, and in this video we're going to be going over variables and how to use them in C++. So variables are basically used to store things in a designated spot using C++. So basically, to do that, we're going to have to use some type of value that can hold that information. So if that makes any sense. So if we want text, for example, we're going to put string, and this is the value or the variable that we use to hold all of our name or all of our characters. So if you have a sentence or any type of text, use the string to hold that. So on the opposite side of that, we have numbers. So if we want to store a number, we use int, or we use float, or double. So there are more variables, but basically these are what we use. So the reason that we have 3 different values for numbers is because integers basically store numbers that have no decimal place. Floats store like numbers that have like 4 or 5 decimal places, and doubles store numbers that have, you know, multiple decimal places, like 10 or more than that. I'm not sure exact on the number. If you really want to look it up, it's not that big of a deal to know. Basically, we're always going to use a float or a double. Integers are used, but you know, basically just for like basic tasks, we usually want to know the exact number that's coming out when we're doing some type of calculation or something. So we use these 4 variables, and we're going to start by making examples. So string, what we do after we write a variable, I'll delete the rest of this for right now. So we just have a string, which is a variable that can hold text. So in here, we make a string, we declare the string variable, then we put the name of the variable. So I can just put text output, and then after that, we can either close it, and that's the end of our variable, and we're just declaring to the program that sometime in this program, we're going to have a variable called text output. Or we can go ahead and make that equal to something that is a string of text. So I could say this is my first string of text, stored in a variable, and then after that you always want to end your lines of code usually with a semicolon, every command is ended with a semicolon, just in general practice. So this is our variable now. So now that we've created this variable, we don't need to go and output that whole string of text to the screen. I can just output that variable to the screen. So as you can see, if I just go and type in the variable and it in the line, just as we did before when I had the variable, or in the last tutorial where we outputted text to the screen, where I put like this is text, and then we ended the line, just like this, we're storing this inside of this variable, and then in turn, we can just call that variable whenever we need it. So as you can see here, if I just take this program now and I run it, outputting the text output variable, what we'll get is that whatever's stored in that variable. So this is my first string of text stored in a variable. I can also change it to, this is my second. Run it again, and it'll again just change it. So this is my second string of text. So basically that's how you store a string inside of a variable. So when we're storing numbers, it's a little bit different. So I'm going to start by using the double, and we're going to say double, just name it. Again, after a variable, you just give it a name. We're just going to put this is a number, and then set it equal to 1052, whatever. And then again, we're going to want to use the semicolon to end the command. Now, after this, I can see out and put this is a number. And as you can see, when you're typing it in, it pops up, so you can just click enter. And then in the line again. So then, I'll have, when I run the program, that number under the string of text, because it runs in the order that they were called. So because I ran the text variable first, it called that, and then after that it said, okay, I'm going to end the line, then I'm going to call this is a number variable, because that's what it says right here, and I'm going to end the line again. But I could also do it in a different way. So I could also say I wanted the program to display text saying, you know, what these variables are. I could say, okay, I'll enter a string of text here that says, this is my number. Put a colon, put a space inside of the braces, and then just put put the output operators or the less than signs, and then call that variable again, put the output sign, and end the line. You can do the same thing up here, and just say, enter a string of text that says this is my text, and then when we run this, we get a little bit more of a clear understanding of what's going on. So this is my text, then it outputs that variable. This is my number, and it outputs that variable for whatever was stored in that variable. So that's basically how you do basic text output, basic number output in C++. And that's all I'm going to show you guys in this video. That's all we need to go over for variables and how to create them and declare them correctly. So thank you guys for watching. If you have any questions, let me know, and I'll see you in the next video. Welcome to TechSpace, and in the last video we went over how to actually use variables. In this video we're going to be going over how to take user input. So if you want the user to enter some information, say for example you need them to say yes or no for a question. So like say I have or I can just say anything. So say you need a user to enter their age. So we can say, please enter your age in that line, and say we want the user again to be able to have some way of entering information here so they can say their age for themselves. So what we need to do for that is type CIN, and then we need to type greater than symbols, just like the less than symbols, but greater than, and this basically says it's going in to your computer, and we're going to want to store that in a variable that we've already created. So if you remember from variables, we store all information in C++ in variables. And almost all programming languages do this, is you take information, create a variable, and you can store that information in a variable and access it later. Whether you can access it later or you can access it whenever, as you'll find out later, some variables are created for public and some are created privately within your program in different functions. But basically, if you want your variable to be, if you want to be able to store information, you're going to have to use a variable, and if you want to access that information, you're going to be able to call it using that variable. So we need to create a variable that can accept age. So remember when we went over the different types of variables for numbers? We had int, we had float, and we had double. Now we just have we're just going to want to use one of these three. So what's best for this is basically just int, because as you remember, it just stores whole number values. It does not do decimal places. So nobody's age is going to be like 23.2. Of course they could enter that, but it's probably not going to be their age. So we're just going to put integer just because we're expecting them to enter a whole number value, and just put user's age. And we do not want to declare their age as anything, so we're just going to close it and say, okay, we have a integer value or an integer variable that is going to be called user's age, and eventually I want to store some information in that variable. So we have to declare that before we do CIN, and specifically because if I was to run this variable and put it below CIN, once I put the user's age in here to call that or to save the information that the user entered, it would say, okay, I'm going to store the information here. Since the compiler reads from top to bottom, it would say, I'm going to store the information here, but this isn't a variable. So here I would get an error, because when it runs this, it's saying, okay, this isn't a variable. It has to be created before you save that information into it. So then we can run our program. So basically it says please enter your age, and as you can see I'll put 22, click enter, and that's it. Program's over. So basically we want to have the computer or the program say back to us, okay, thank you, or thank you for entering your age, and then output the age that was entered. So I'm going to go output, then we're again going to use some text, and it's just going to say thanks for entering your age, and then we'll end that line, and then we'll just say your age is, and we'll just call that variable and end that line again. So as we gave it some space here, and since the variable already has the information stored in it from right here, when I output the variable to the screen, it should, and it will, show the information that was stored in here by the user during this first string of text where it said please enter your age. So we run it again, please enter your age, 22, and it says thanks for entering your age is, and 22. If you have any questions, please post it below. Thank you guys for watching, and I'll see you in the next video. Welcome to TechSpace, and in this tutorial we're going to be going over a thing called the if statement. Basically what the if statement does is it takes two variables and it tests them, or it takes one variable and it can test it, and checks and sees if that statement is true, and if it's true it will run the bit of code inside of it. So if you can see here, my main is clear. We're going to create an if statement. So first I'm going to actually create two variables. Integer x, just set it equal to 20. Integer y, just set it equal to 35. And then we're going to go and create an if statement. So what we do is type if parameters and then a body. So everything, we need parameters and a body, just like a function does. And we don't want any space between the if and the parameters. But basically inside the parameters we're going to need to put some type of argument. So the argument is going to be if x is greater than 35, then I want to run whatever is inside of here. You win the contest. So basically, if x is ends up greater than 35, you can print out this set of code. So if it is, we'll get this set of code, but if not, we won't. So we know that x is not greater than 35, obviously, which I shouldn't have used that example. What we want to do is put x is greater than y. So if we put x is greater than y, we'll have the value 35. My bad. Okay, so that's what was sort of stumping me up. So if x is greater than y, then you won the contest. What we're going to do after that is just put another if statement and just say if x is less than y, you lose the contest. So basically what our compiler is going to do is it's going to take in them two variables, it's going to run through this one if statement, and it's going to see if it's true or false. So in this case, we already know x is less than 35, so this is going to be a false statement because x is not greater than y. So we're not going to get u in the contest, but if you look, x is less than y, obviously, so we should get the contents in here to print it out on the screen. So when we run this, you lose the contest because x is less than y. Now if I change that to, if I change x to 200, I should win the contest because now obviously x is greater than y, which means I'll get the contents in here. So I can go ahead and run that, and we get u in the contest. So next, what we want to do, just to show you a little bit more about the if statement, is there's a thing called the if-else statement. So the if-else statement says that instead of writing those two things, I can have one condition which says if x is greater than y, then run this stuff, else, which you want to put that at the end of the bracket after the if statement, else run this set of code. So now in this set of statements, you'll get whatever, if this statement becomes false, it will run the else statement. Now if this statement is true, then it'll disregard whatever is in the else statement and it won't run it. So what we'll say is you lose inside of here. Instead of writing two if statements, we can just use this. You lose the contest in the line, and basically x is greater than y, so we're going to get you win the contest. We'll go ahead and print that out. You win the contest. Now what we're going to do is go back to 20. X is not greater than y. So when I run this, you lose the contest because since it ran this and it said, okay, this isn't true, this is a false statement, so I'm going to run whatever's in my else function, which basically means if this argument is false, then we're just going to resort to running the else. So inside of our else statement, all I had was the basic output of you lose the contest, which is what we got right here, and that's what we expected to get right there because x is in fact less than 35, which is false compared to these parameters. So if I was to change this again to x is less than 35, then I'll get you win the contest again. So you win the contest, and that's basically how you do it. So that's basically how you're going to use the if and the if-else statement. So the if statement is different from using the if-else statement. Remember that. So you can use an if statement by itself, and this would just be fine without the else. But if you want this to run, and then, if that's wrong, something else to run after it, you can use the else function to help along with that. And you can also, again, take the variables, make them declarative, or make the user input the values for x and y, as we did in the past, and just say, enter a value for x, and then store that information in the line, and then we're going to store the value for x, of course, in x, and then we can just say cout enter a value for y in that line, and just store that in y. In this way, the user can go ahead, enter their own information here. So enter a value for x, 5, enter a value for y, 3, and since 5 is greater than 3, when we go back to our thing, 5 was stored as x, 3 was stored as y, and x is greater than y, it's not less than y, so I would not get the contents in here because this argument becomes false. And since it's false, we get the else statement. And again, I just wanted to emphasize this to the full extent so you guys understand exactly how this works and exactly how it runs. If you have any questions, post them below. If not, I'll see you in the next video. Welcome to the Tech Space, and in this video we're going to be going over arrays and how to make arrays in C++. So basically what arrays are arrays are variables that can store multiple types of information, or not multiple types of information, but multiple values. So say we have an integer x and we have one value stored in it, because we know if I create an integer x, I can only set that equal to some integer like 50. I can't set it to 50 and 54 and then end it, because when I go to cout x, and in that line, we're going to get an error because you can't store two integer variables in x because it's only made to store one value or one integer. So basically what we do to fix this is create an array. So arrays are basically the same thing as a variable. Same way, just declare the variable and we'll say double, give it a name, and this is going to be number. And I'll say number n, and then we're just going to set that. After that you put brackets. So these brackets, the square brackets, are going to be used right after we name that array with how many elements we want in that array. So instead of just storing one value in an integer or in a variable, we can now store several. So I can store 5 double variables inside this array, and this will be equal just like a regular variable would be. I can store now 5 double variables. So I can say I want 60, 67, 34, 20, and 34, and that's 5 variables. So now I have 5 numbers that are of the integer, or not integer, but they're doubles, and they're stored in this array of 5 elements. And you want to put the elements inside curly braces and end that with a semicolon, separating each element with a comma. Now, why this is useful will come into play later on in programming, but this is very useful because you can store tons of information in arrays without having to say, integer, or in this case, we'd have double n is equal to 60, then we'd have, double h is equal to 67, and then we'd have to keep going on and on to create all these variables for all these different numbers. So instead of doing that, I can just store all of these in an array, and then when we want to access one, we just output 1 to the screen. So the way we do this is a little bit different. When you want to call an array, we want the variable, we want the brackets of course, and we're going to want to have the inline. Well, you don't really need the inline, just makes it look a little cleaner. But inside these brackets, we're going to need to call the number that we want. So we're not going to enter the number directly. So if I want 60, I'm not going to enter 60 inside these brackets. What I'm going to do is enter 0. So when I put 0 in here, I'm calling the first element in that set or that array. So in this array, I basically start with element 0, and that's basically what they're called. So I have element 0, element 1, element 2, element 3, element 4. Now there's 5 things inside this array, but this is how we're going to be calling them. So this is named 0, this is 1, 2, 3, and 4. So we never really get a 5th element because in computer languages we usually start with 0 instead of starting with 1, which is how we count in our natural world. So we start with 0 and use 0 as an actual object. So since we're doing that, we're gonna access this by putting 0 in between the brackets, and the computer's gonna say, okay, that's the first element within this set or this array. So when I output this, it's gonna say 60, which is again 0, or the element in position 0 inside of this array. So if I close this and I just say, I want to print out every number, or every number inside that array, what I can do is just copy this, paste it 5 times, and I want 1, which is going to call 67, 2, which will call 34, 3, which will call 20, and then 4, which will call 34 again. So as you can see, 0, 1, 2, 3, and 4 is how we're going to be accessing the things inside this array. We'll print it out, and there you go. You get element 0 through 4, or element 1 through 5, however you want to look at it. This is very important to understand. So just remember that when you're doing it, you count from 0 and then you start, not from 1, 0. And you can easily test that by just plugging a number in here, counting the positions, and figuring it out that way. But remembering it is basically essential to programming, so make sure you remember when you're accessing variables or elements inside of an array, you need to start counting with 0 to declare the first element, and so on to declare the other elements in the array. So that's how that works. Thank you guys for watching. I'll see you in the next video, and if you have any questions, post them below. Welcome to TechSpace, and in this video we're going to be going over how to use different functions other than just the main function. So far all we went over is there's a main function, and we can enter variables in here, take user input and display output onto the program, but basically everything we've been doing is inside of this main function, and that's what it's called. It's called a main function because that's what it is. It's the main function of your program. But besides that, we can create other functions. And remember when there was the return sign and it said return 0? This basically meant to end that program. So you wouldn't want this outside of this program, or outside of this main function, because you don't want to terminate the program before the main function runs. So before the program can run successfully, everything is ran through your main function. So no matter how many functions I create, they have to have some link to the main function in order for them to work in your program. So I'll show you how to create a function really quick, and it's just how we created this function. So we have a variable type, and I'm going to introduce you to a new variable for functions that do not take any return value, which means something that's not going to be doing a calculation, something that's just going to say print something out on the screen. We can use the value void. So void just means, okay, I'm just going to create a function. It's not going to do any calculations. It's going to be very simple, and that's all it is. So we're going to say void function 2. We're going to have no parameters, and we're going to create the body with our curly braces. So basically in here we can write anything that we would in a normal program. So what we're going to do is just say cout, this is my first program, or my first function, and then in that line. And of course you can do anything else in here. You can take in user input and blah blah blah. You can do whatever you want. We're going to take the user input of x, and x is just going to be, you know, some number 34, whatever is the variable. I'm going to create a double, number 34, set it equal to, you know, 23 point, blah blah blah, end it, and then we're just going to say, you know, after I created that variable, I want to see out my number in that line, or actually no, not in that line. Then we want to output the variable, number 34. And again, this is just an example of, you know, how to call, how do you enter information in a different function other than main, and get functions together. So basically, the basic function of a function is to group different tasks together. So if I wanted this function to do this task, so I have a variable called number 34, I'm going to see out my number, and it's going to say whatever number is set to this, so it's going to output this number. Then after that, it's going to end the line, then it's going to say this is my first function, and then it's going to say enter another number in that line, and then we're going to save that number into a variable x, which we have to create again inside this function. Don't set it to anything because the user is going to set it to something, and then it's going to say here's your number. Okay, if I can get this written in there. Here's your number, output x, whatever the user entered. Now when I run my program, nothing pops up. So you're wondering, okay, so I made this function, I did everything right, didn't have any errors, but where is everything at? So basically to call a function, we're going to have to do something called exactly that, calling a function. So, like I said earlier, everything has to go through your main function in order for it to work in your program. So what we need to do for this is take their function name and our parameter sign, copy it, go down to main, and paste that in there, end it with a semicolon, and that's it. So now that we have this, as soon as our main picks up, okay, function 2, it's going to look in the program somewhere for function 2, and it's going to say, okay, function 2 has already been created, I already know what it does, so I'm just going to go ahead and run it for you. Now when I run it, it says my number, the number I entered or saved to that variable, this is my first function, and enter another number that's going to be stored as x. So I can just go ahead, enter my number, and then it should say here's your number, and spit the number back out to me. So we're going to say 50, here's your number, 50. So that's basically all I need to show you guys in this video. I'll see you in the next video. If you have any questions, please post them below. Please subscribe, and as always, I'll see you next time. Welcome to TechSpace. In this video, we're going to be going over parameters and how parameters are used in functions. So basically, we know how to make a function, and we know that functions can come in different types, as in void, that doesn't have a return type, you know, integers, doubles, and all types of different functions that can be declared. So in this one, we're going to be doing an int function because we're sort of going to want a return type. So basically, we're going to give our function a name. I'm just going to name it something, you know, basic as always. Nothing too complicated because we really don't have a, you know, primary use for this function. We're just, you know, trying to go over how it's going to be used. So we have an int called function2, and as we know from earlier, to call that function into our program, we have to actually use it in main by calling it just function2 and using the parameters of any. And in this one, we're going to be using parameters because this tutorial is about parameters. So basically what parameters are is they're pre-made variables that are stored into a function in order to define that function to those set of variables. So if I have an integer x inside here, I'm saying that inside this function I have an integer x, and primarily integer x is what this function is going to be built around. Now I can also put a comma and just create more parameters, such as integer y. And we're saying now that in this function I'm having two integers and one x, one y, and they're going to be doing some type of calculation, or they're going to be this function is going to be completely defined by that integer x and that integer y and what they're doing in this function. So what we're going to be doing with those is we're going to be returning. To do that, we're just going to type return. And what return is a little different than cout, where you're displaying something on the screen or you're giving some value to the user. What we're going to be doing with return is saying, okay, in this function, all I want to return is x plus y. Now, just as you do in math, just add the normal plus sign, and we're saying, in this function that has parameters, or, basic ingredients of integer x and integer y, which I could have named, strings or doubles, we're saying integer x and integer y are going to be the main ingredients of this function. And in this function, all I want this function to do is to return me the value of x plus the value of y. So when I run this function, I should get the value of x and the value of y. Now there is no value for x and y, so I could of course do the thing that we've been doing, which is say create a user output, or create enter a value for x, and then in the line have the user enter something for x. Of course we could do that, and then we could do the same thing for y, enter a value for y, and then have the user enter something for y. Instead of doing that, we're just going to say, okay, return x and x plus y. We're going to call that function, and we have to give these x and y we have to set them equal to something. So inside of our function, I'm just going to say x is equal to 45, y is equal to 46. Now since I already declared them up here as integers, I don't need to declare them as integers down here, because the compiler, the computer already knows, okay, x is in this function, and it has no direct value yet, but down here I see that x is now going to be set equal to 45. Since it's an integer, that's an acceptable value. If it was a double, I could put 45.45272, but it's not a double, so we're just going to use a regular integer value, no decimal places. Same for y. And I'm just going to return x plus y, and then of course run this function in our main function, because all functions have to be ran through main to be called to the program. So when we run it, as you can see, we have the function not working. Why? Because when I declared these two variables up here, I didn't say, alright, when I declared these two variables up here, that's not how you want to do parameters. So in a function, we have parameter x and y. So they're both integer values. When we call that to our main function, we're going to want to set the values within the parameters of our main function. So I want to say 50 and then 60, and I don't have to say again x is equal to 50, x is equal to 60, since I know that I have function 2, it takes in two parameters, and all I want them parameters to do within that function is return me what x is plus what y is. Now, x and y aren't declared, but when I called the function in my main function, I passed through the value 50 for the first element, and then I passed through the value 60 for the second one. So, if that makes sense. So when I call this, I should get 110, because I'm doing x plus y, and x, which was declared in function 2, is set to 50, and the y is set to 60. So when I run it, we get nothing out on the screen because I made a mistake here. So since we called this to our main function, that's fine. Everything is working perfectly, which we can do by clicking the rebuild, and it says process terminated with status 0, which means that we have no problems, no errors. But we have to say cout again, as always, because without cout, we're not going to get anything on our screen. So we want to now cout that function too, with the same parameters, 50, 60, and then we're just going to end that line. Rebuild and run it, and as you can see, we got 110. So we're going to be doing that next tutorial. Thank you guys for watching, and I'll see you in the next video. Welcome to the TechSpace. In the last tutorial, we had a function as shown on the screen. Function 2, it took 2 parameters, it returned x plus y, and then we of course called the parameter in main, and we were going to run the program and it failed, and that's because of a thing called function prototyping. So what function prototyping is basically, like I said before, your compiler runs from the top to the bottom. So when it sees something up here that's already called, but it hasn't been declared yet, so like I have function 2 in my main, I'm saying, okay, run function 2, but it doesn't know what function 2 is yet because function 2 is down here. We have to create these things called prototypes, which are basically representations of what that function is, so that our computer knows that we want that function to be used anywhere within our program without having to write it on top of our main. So as you can see, if I run this, we get a fail because it doesn't know what function 2 is, because function 2 is below main and has not been declared. When we run it up top, the program runs perfectly because it declared, okay, it took function 2, saved it, it knew all the information about function 2, and then we passed the values to function 2. So since it already knew what function 2 was, it had no problem running it. But if we run it on the bottom again, which is something we don't want to do in programming, you don't want to have to always create your functions on top of your main, just because it's, it comes on very hard to organize. So what we do is we do this thing called function prototyping. So again, if we run this, we get a failed because it doesn't know what function 2 is. But if I take this whole line right here, excluding the brace, copy it, put it above main, and then put the semicolon, this is called a function prototype. So we're basically saying, in this program, I have integer function 2 that takes the 2 parameters, one integer x and one integer y, and I'm going to use it sometime. So just reference this. I want you to know this information before you do anything else. So before you do any other calculations, any of our function prototypes up here, which I'll actually put function prototype. And I don't know if I showed you guys this yet, but if you put 2 forward slashes, you can get a comment. Comments don't affect the program. It basically is used to organize things. So I can say function prototypes, which this will be all the information or all the functions that are going to be somewhere in our program, but we don't want to specifically have to write them on top of our main. So we're just going to declare that that information is on the program, and the program is going to see this and be like, okay, I know this function because it's down here, and I can locate it now before I run the rest of everything. So when I run this with the prototype, it runs just as it did when we had our function above our main function, because it knows about the function before the function is declared. So we can do the same thing. If I create another function, I'll just say integer function 3 or 4 or whatever, and we do the same thing, you know, and I just take integer t, integer p, and actually we'll do this one without parameters. So we have function 4, and on function 4 I just want to see out today is Sunday, end line, and basically all this function is going to say today is Sunday, but since it's below the main, we're going to have to prototype it. So again, if I go to try to run this, and I say, hey main, I want you to go ahead and run function 4 for me, and then I want you to run function 2. It's going to say, okay, well, what's function 4? Because you don't have a prototype for function 4, therefore I don't know what that is. So what we're going to do again, just like we did before, even with no parameters, is we're going to take this integer function 4 with the parameters, whether they're empty or not, copy it, paste it up here on top of everything, end it with a semicolon, and that's prototype. So now, again, our computer knows function 4 is somewhere in here, so when you see it in main, don't freak out, just hurry up and call it. You already know the information inside of it. And same thing for function 2. Since function 2 is prototyped, we already know about this, so when I see it in here, I'm not going to take it by surprise. I'm just going to go ahead and perform the job of that function. So when I run both of these, I get, okay, function 4 ran perfectly, it just see out today is Sunday, and then I get function 2, which was called second, with my parameters correct and everything. So I can close this, and again, if you want these values different, you can set them literally to, you know, anything you want. 8,700 plus 6,000, because again, these parameters are being ran through this function. These values are being ran through this function, and these are actually declaring the values in order of the parameters that are set to the function. So while that might not make sense, if you watch the tutorial on functions, you definitely get what I'm talking about. If you watch a tutorial on parameters, you get what I'm talking about. Only thing that you need to know about this is when you're creating functions, you have to prototype the parameter, well, the type of function, the name of the function, and the parameters in the function above everything else in the program, so that your program knows that that function is somewhere in that set of code, so that when you go to your main and you go to call that function, your main doesn't freak out about it. It just understands, okay, I have this function, this is what it does, and I'm going to run it how it's supposed to be ran. Now, on the contrary, if I have a function written above main, and it might, like if I have function 4, delete it from here, and put it above main, I don't need this prototype, because when the function, or when my program runs, it's going to read function 4 before it even calls function 4. So, I don't need the prototype for function 4, as long as it is, again, above the main. But if you are, you know, like 99% of other programmers, you're not going to like this. Eventually, you're going to get tired of having to write everything above main, and then scrolling all the way down to find main, so that you can call your function. You're just going to say, screw that, I don't want to do that. I can just write my function wherever I want, it doesn't matter, as long as I have, you know, my function prototype. Very important to understand how function prototyping works, and how parameters work when using function prototyping. But thank you guys for watching. If you have any questions, again, leave them below and I will answer your questions. Other than that, I'll see you next time. Welcome to TechSpace, and in this tutorial, I want to go over having multiple conditions inside of an if statement. So, if statements, as we went over earlier, were just, you typed in if, and you had, you know, if x is greater than y. I think the example I did was, then, you know, print out, you know, you win. Well, besides that, we went over the if else statement. So you know, if x ended up to be less than y, then we just run, you know, this statement. So what I want to go over now is, besides the if statement and the if else statement, there's conditions that we can add in the if statement to, you know, make it a little bit easier, so that you don't have to write a whole bunch of if statements or a whole bunch of different if else statements. So what we can do is say if x is greater than y, and let's create some variables first. So we're just going to say integer x is equal to 10, integer y is equal to 12, integer z is equal to 20, and we're just going to say f of x is less than or equal to 10, or fx, which is 10, is less than or equal to 12, which is y, and we can have this thing called logical operators. So what logical operators are basically what I just wrote. So we have less than or equal to. We've been using them the whole time. I just haven't really introduced them. So we have logical operators, and basically those are these. So we have less than, greater than, then we have less than or equal to, or greater than or equal to. So basically we can say if x is less than y, which obviously we know x is less than y, so we're going to make this a true if statement. We can use this logical operator and, or ampersand, which is the 7 button. Hold down shift, press the 7 button, and we're going to say and x is equal to 10, which is another logical operator. So we have, when we set something equal in an if statement, we can't just use one equal sign. We have to use two equal signs, because that's how, you know, it's denoted. So we're going to say if x is less than y, which it is, and x is equal to specifically 10, then you win. We run it and we see, okay, we won. Why? Because this condition is met perfectly. X is less than y and x is equal to 10. So again, when we're saying something inside of an if statement as a strict equality, so we're saying x is strictly 10, then we have to use two equal signs. When we're saying two conditions have to be true, then we have to use two ampersands. So I could also do, you know, x is equal to 10, and we're going to say, and z is equal to 20. And run it again, and I still win because z is equal to 20. Now if I say and z is equal to 21, meaning all three of these have to be true, we see that this is going to be false. So what we should get is nothing back on our screen. See? So we get nothing back on our screen because it didn't meet all three of these criteria. So when it does meet all three, we get it. And it's because the condition is true, the condition being everything inside of our parameters in the if statement. So since the condition is true, we have the output of that set of rules inside of that program. So now what we have is, you could say, well, I want to know if x is less than y, or I want to win this game if x is less than y, or if x is, here, so we'll delete the z factor. So we're going to say if x is less than y, and, well, we know and, so we're going to say or, which is this sign. So we use double bars to represent and. So the bar is above enter usually. Just for shift and the button above bar, or the button above enter, and that should be the bar button. And this basically says or. So we're saying if x is less than y, or we're going to say z is greater than or equal to 10, then we're going to win. Else, we're going to say you lose. And I'll just make this a little different. We're going to say string output 1 equal to you lose. And that way when I say cout for else, I can just say output 1 and that line, and then we're just going to say, you know, just have another output 2, we're going to say you lose, go home. And we're going to end that variable, and again these are string variables, so we're going to say output 1 in that line, and then we want to also say output 2 and in that one. So if x is less than y, which it is, and z is greater than or equal to 10, which it is, then I'm going to get you win, else it's going to say you lose, go home. So I get you win. Now since it's or, that means if either one of these are right, we're going to get we're basically going to get everything inside of this if statement returned to us, or returned as true. So if this condition is true, or if this condition is true, we'll get this result. But if they're both false, like say we say x is greater than y, which we know is false, and z is less than 10, then we know that both of these are going to be false. So since they're both false, we're going to get the else statement, which says you lose, go home, because neither of these is true. See? You lose, go home. So, if that makes sense, you can sort of ignore these string variables. They're just, you know, to add a little bit extra. What I want to get across here is that there's things called logical operators, and I'll make a list right here. So, we have, make a comment, logical operators. And these logical operators are and, bar, then we have less than, greater than, less than or equal to, greater than or equal to. And the equal sign always goes on the right side. And then we also have is just strictly equal to. So these are the logical operators we can use. So and means that if both conditions are true, and this bar means if one of the conditions is true. Then we run the statements inside of that if statement. Else, if this fails and this statement is false, we're going to output this. So we have logical operators which can be used inside if statements, and later on you'll see they can be used in multiple different places and are very helpful, especially when doing math and calculations and even basic stuff within C++ and other programming languages. You'll need these logical operators as reference, and you'll need to know what they do, because in each programming language they're going to be virtually the same. But basically, that's all I need to show you guys in this video. Make sure you understand how logical operators work. Make sure you understand how to use them in if statements, and make sure you understand the variables, and that for each logical operator we are testing the condition for if one of the values is true, which is or, if both of the values are true, if a value is less than, greater than, less than or equal to, greater than or equal to, or just plain equal to the other statement. And then if this is true, which this condition is true, then we run this code, else we run this body of code. And remember to use the braces, and for reference, if you click on one of them, it'll show you what group it belongs to. So as you can see, this belongs to the else group, these braces belong to the if group, and if I even click on main, it'll show me the end of the main group. So that's how you create if statements using logical operators, and this is how you use multiple conditions inside of if statements. So thank you guys for watching, and I'll see you in the next video. Welcome to the Tech Space, and in this tutorial I want to go over basic math functions that are used in C++. And since this is tutorial 13 now, or 12 or 13 now, I figured we'd go over these math functions and set them into a different function. So we're going to go ahead and create some function. We're just going to create a void, and it's going to be called math formulas. No parameters, and we're just going to create it just like that. Now inside of here, what we're going to do is create two variables. Well, actually, I'll show you how to create multiple variables. So we have, instead of going into x, into y, when we're having the users input information, we can just store it just like this. So integer x, comma y, comma z, comma c, comma v, and then put that. So instead of an array, we're not declaring the value. So if we had an array or a certain amount of values that we'd want, say we wanted 5 values, I could just say integer, x, and I want 5 values, and I want to set those 5 values equal to, blah blah blah. I'll show you, give you an example. So we want these 5 numbers to be stored into this array, which is called, X array, and it has 5 elements inside of it. So this is when we want to declare the variables strictly. So when we want to give the variables an actual value, we can do this. But when we want the user to input the value, we can just go ahead and do a line of code like this up here at the top, where we just separate the variables by commas, ending them with a semicolon. So when we're declaring the variables, use an array, but when the user is going to be declaring the variables, we're going to use just a comma list of the variable names. So the variable names, again, could just be anything. I just use single letters because it is just going to create, ease as we go through, how to do math functions. So while they're not hard, math functions can get a little different. So what we're going to say first is we want the user to be able to enter values. So we're going to say enter 2 numbers to get multiplied. And then we're going to end the line, and then they're going to enter a number, say whatever, and it's going to be stored in X. And then they're going to say, I'm going to say enter another number, and it's going to be entered in Y. Now after that, the user has already entered X and Y, so we're just going to see out, and we want to multiply those numbers. So what we're going to do is say X, and then use the 8, the button, the symbol for 8 on the keyboard, and then we're going to say Y. And then we can end the line, or we can even do this and just put answer colon X times Y, and then end that line, so that when the user enters XY, we now have our operator, our math formula, which is just basic X times Y, and it's just going to take X and Y and multiply them together. And we got none on the screen because I forgot to call the formula inside of our main. So the function is above main, so I don't have to create the prototype. and enter two numbers. 6 times 6 is 36. So we can do the same thing, add, you can just say added together, and then x plus y, we'll enter the same two numbers, 6 plus 6, 12, and so on and so on. We can do minus, and I'll put range in this, subtraction, x minus y, 6 minus 3 is 3. And then the last one, divided by y, and of course I'll enter something that brings out an even number since we have integers, and again this is where integers are going to come into play. So we're going to do 9 divided by 3, and we're going to get 3. Now I'm going to run this again, and I'm going to do 10 divided by 3. So 10 divided by 3, and we get 3, because integers aren't made to store decimals like I said before. So if we want it to store a decimal and return a decimal, we use float or double. And since I'm going to get a little bit longer double, or a longer decimal, say we want this to be a very precise calculation, I can use a double, and it will return is think 8 decimal places. So we'll run this, enter two numbers to subtract together. We'll change that. Say divide, don't need together, and then we're just going to run it, and we're going to divide 10 times. 10 divided by 3 again. So as you can see, we get 3.33333, so it goes down 5 decimal places. So this is a very accurate number compared to, if we were to use integer, because integer isn't going to give us the decimal. So the last thing I want to do, so we have 10, and say we divide it by 6. Again, we're going to get 5 decimal places. Okay, so say that you want to know, we're going to run the same program. Say that you wanted to know the remainder if you had 10 divided by 3. Say you just didn't know how to do division, and you wanted to know, if I divide 10 by 3, what's left over? What didn't divide into 10? So we get 3.333. Yes, that's the correct answer for this math, but what if we wanted the leftovers? So we wanted to know the remainder. We can do this. So we have x, and what we're going to want to do is type the percent sign and then y. So it's going to take x, it's going to divide it by y, but it's not going to give us the value of x divided by y, it's just going to give us the remainder of what's left over. So that's basically how you run formulas and math formulas. You just output the values, multiply them, subtract them, add them, divide them. You can do whatever you want as the user takes in input. So again, this works for every single type. So I could use this as a parameter. I could use math formulas, say x times y. I could take that and just say, okay, I want a double that holds x times y, or double that is equal to, let's say, equation 1, and that's equal to x times y. And then when I go to output, I can just say I want to use equation 1, because equation 1 will multiply x times y. Well, if I don't want to multiply, I can just use equation 2, which is going to take x and just divide it by y. So I can just say, okay, and now I want to use equation 2, because equation 2 does division. So let's mark these so we know which one's which. So we're going to say equation 2 is the division equation. And then we're going to say equation 1 is the multiplication equation. So now what we have, multiplication equation and our division equation, and they already have the user enter values, and they've already done the calculation, and they already have the results. So when I output the variable already is holding the result of x times y and x divided by y. So when I run this, I get enter two numbers. Actually, we'll fix this. So enter two numbers. In general, enter two numbers. 916, and let's do something different this time. 6 and 10. So in multiplication, we get 60. 6 times 10, 60. 6 divided by 10, 0.6. And since I use doubles, I get the actual decimal point for those variables. So I get 9, 3. We get 9 times 3 is 27. 9 divided by 3 is 3. And we can do this for every single arithmetic operator that there is. So basically all we need to know is that arithmetic operators in math you can use by using these symbols right here. I'll do all four of them. X minus y, so we have multiplication, division, subtraction, and then we have basic addition. So x plus y, and then we can eventually use those equations to show up on our screen as answers. So we can set equations using math to different variables, and when we set them to different variables, it saves the equation as that variable. So we no longer need to, go in here and see out x times y. We can create x times y and then just call upon it when we need it. We can create x divided by y, then just call upon it when we need it. But the important part is to remember the operators and how math is done. So remember those, and remember that you can create variables that have not strict declared values that the user is going to input by separating the names of them with commas and then just ending it with a semicolon. So I have x, y, z, c, and d, and none of them have a specific value until I have told the program to let the user give us a value to store in that variable. So until I say store a variable in z, the computer won't store a variable in z, and I haven't declared that, so it's only taking x and y. And since these haven't been used, they're not going to create an error. They're not going to do anything. You can use them whenever you're ready, and then you can even take them out. Since we didn't use them, we can just say double x and y and declare those two variables together. But the important part again is to remember these variables, and remember how to do math and how basic math is carried out, because it is used a lot in C++ programming. Other than that, I'll see you next time. If you have any questions, leave them below, and I will see you in the next video. Welcome to the Tech Space, and in this video what we're going to be going over is something called the while loop. So loops are something new in this tutorial that we haven't went over yet. So basically what a loop is in a program is something that's going to occur more than one time, and specifically it's going to occur a certain number of times. So basically if you have a function that you want to run, say 40 times in a row, then you maybe would build a loop for that program to run in. So basically I'll go ahead and show you what it is. So what we have here is something called the for loop, and well, we have two different types of loops. In this video I'm actually just going to go over the for loop. It's simpler. The for loop basically is something that is used again to make your function or some set of rules run over and over again. So we write for, set of parameters, and then the braces that we need on basically every element in C++. So in for, what we're going to have is three things. So what we want is an integer. Let me write this out first. So we have integer x, so we're going to say for integer x is equal to 0, x is less than 10, x plus plus. Now what this means, okay, the first part of this, okay, well, first I'll start with this. So for is a loop. For is a type of loop. And that loop allows this this argument to happen. So integer x is equal to 0. That's what we're saying. Now we want this loop to occur as long as x is less than 10. So since x is less than 0 and we want this to occur, then while x is less than 10, we have to have something that makes x change, or this is always going to just keep running because there's nothing to stop it from 0 ever being greater than 10. So that's where this last part comes in. And by the way, you want to separate these with semicolons. So after you declare your variable, and again, you could have used that first thing. We could have just declared like this, integer x is equal to 0, and then in here, just put integer x, or again, we can just declare it in here, and then get rid of this line of code. So we have integer x, semicolon, x is less than 10. So while x is less than 10, we're going to run this stuff in here. Now this last part, x plus plus, is the incrementer. This increments x by 1 every time the for loop is ran. So every time this runs, x will become the next number up. So x will be 1 after it runs once, x will be 2 after it runs twice, x will be 3 after it runs 3 times, and so on and so on. So eventually x will become greater than 10. So we'll make a little bit of sense. We're gonna say this is a string of text. Something very simple, because it really doesn't matter. I just want to show you the concept of this, and everything in here will come after. So basically, if I go ahead, if we go ahead and run this, you'll see we get, this is a string of text 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. That's because once we ran this, we said, okay, we want this to run while x is less than 10, starts at 0, 0 to 10, that's 10 elements. So we ran this 10 times because it incremented by 1. Now, we could have easily just said, you know, I want it to run 1,000 times. Close this out, rerun it again, and it's going to run 1,000 times. It ran until it hit 1,000, and then it stopped. That's because, again, it was incrementing by 1 every time. Now, we can also do something else. So we can say, you know, while x is less than 1,000, I'll do 20, but instead of x, okay, so x plus plus basically is a shortcut for x plus equals 1, which means x, the value of x, which is 0 at the moment, plus x plus 1. So basically this means in arithmetic, or how we write this in algebra, would be something, we'd write this, x is equal to whatever the value of x is plus 1, end of the story. So technically I could just write this down here in our for loop, forget about it in the argument, and just write it here. X is equal to x plus 1, and it'll increment by itself because it's running this code in the loop. It knows x is equal to 0, And since this loop is going to run 20 times, it's going to have to stop at 20 because it started at 0. So there you go, 20 times. So we can also start, at 10. Started at 10, I wanted to increment by 1. I'm going to get 10 text. I'm going to get this printed out 10 times because the incrementer is still here. And again, that is called the incrementer. So x plus plus just means x is equal to x plus 1, or in coding programming language, we say x plus equals 1, which is again the same as saying x is equal to x plus 1 and then x plus plus. So these three statements are the same thing. Now that I've said that, we don't need to increment by 1. We can increment by whatever number we want. So I can say x is equal to x plus 10. So if you think about it, we're starting out at x is equal to 10 and we want it to be less than 20. It's never really going to hit 20 because it's less than 20. So we have to say less than or equal to 20 to include 20 in that set. So if we have less than, it's going to stop at 19. So when we add 10 to 10, we're going to get 20, and it's going to be a false statement, and it's not going to run. So once we add this, we're going to get this out once, because when we add 10 one time, it's already equal to 20. So when we add it twice, it's going to be equal to 30, which makes this false, which makes this statement terminate. So now, hopefully you get it. Once the statement is no longer true, it can't run again. So if I have my incrementer as anything that becomes true or becomes false, then it will always stop the program. And that's important because if you don't have something to increment, basically what we're saying is this: I never want you to ever stop printing out that text, and it's never going to stop. As you can see it popping up down there, it's running it. It's not going to ever stop because the loop is never going to end. The loop cannot end because there's nothing to stop x, or it's not stop x, but there's nothing to make x equal to anything else because there's no increment. So we can see this a little bit better if we just go and don't end the line in the program, rerun it, and as you can see, you get this bunch of, it's the same string over and over, it's just not ending the line. And you can see that it keeps going. But when we do x plus plus, we get a specific amount of times that string of text or them commands within that for loop will be ran. And that's basically what a for loop is, and what an incrementer is. So what to take from this is that, one, this is where you're starting it. This is your starting point. This can be set to equal to anything. It does not have to be equal to 0. It can be equal to anything. What the middle piece of information is for is how many times do you want this for loop to run? How many times do you want the content in here to run? And that can be any amount of times as well. And to set that, we use the arithmetic operators that we learned before, which can be, less than or equal to, greater than or equal to, or just, plain old equal to. Remember to use 2 equals 2 signs. But when we're declaring a variable, we don't use 2 equal signs, but when we're using arithmetic, we have to use the actual arithmetic operators. So I hope that makes sense. Once you write a lot of code, you'll get used to it. Not even a lot. Once you do this a few times, you'll understand the gist of it. But basically, you want an incrementer so that this stops running. And anything in here can be anything. So it doesn't have to be a string of text. I can do what we did in the past and say, enter numbers and do all that crap. But the basis of this is that we're going to be able to run functions and do certain tasks a specific amount of times and use the least amount of code possible to make that happen. So that's basically what a loop is, and we'll be going over loops and functions and stuff like that, and it will all tie itself together. So when we put this all together, we'll be able to create programs such as stock generators, random number generators. You can create games, you can create anything using these types of techniques. And trust me, when people are creating software and games and anything, apps, anything that has to do with programming, they're using loops, they're using variables, they're using this set of recursion and incrementers so that their programs run how they need to be ran, which again will become more apparent as you learn more and more about C++ and what it does and how it works. So in the next tutorial, we're going to be going over while loops, and while loops are a little bit different from for loops, but now that you get the gist of how a for loop works, the while loop should be no problem to learn. Thank you guys for watching, and I'll see you in the next tutorial. Welcome back to the Tech Space, and in this video we're doing the while loop in C++, and basically how the while loop works is I basically have a syntax set up here. We have while and a set of parameters, so just like the for loop sorta, but it's a loop. So remember, loops run until the statement becomes false. So we're going to create two variables inside of our main function. And we're just going to say int x is equal to 0. Remember, just like we did in our for loop, we had some type of variable and we had it set to 0. And we said, what for, x is equal to 0, and x is less than 10, use that incrementer x plus plus, and we're going to run that, from 0 to 10 times because x will equal plus 1 every time it runs. So while that might be a mouthful, that's basically what a for loop does. It is what a for loop does, and a while loop sort of works like that. So we have a while, and of course we have our braces after here, but inside our parameters, what we're going to say is something like we would in an if statement. So in if statements, you remember we use logical operators, arithmetic operators, whatever you want to call them, to basically compare two different variables to check and see if they're false, and then we said, and if this other set of variables is true, then you can run the code. But while says basically, okay, so we're going to say x is equal to, we're going to say, well, yeah, okay, so instead of declaring this up here, we're going to say declare it inside of while. So we're going to say while integer x is equal to 0. Oops, sorry. So basically, we'll leave x up here, I guess, whatever. So integer x is equal to 0. So we have while integer x is equal to 0, and integer z so we'll say, actually, we'll do it this way. Okay, so our while loop basically takes if statement conditions. So what we're going to do in the while statement is create the incrementer. So I want to say x is equal to x plus 1 already, or remember I can just say x plus equals 1, and then we just want to put z plus equals 1 or z plus equals 1, however you say it. And basically, while x is, we're going to say less than or equal to 100, and z is less than or equal to 100, which means we want this loop to run 100 times. So while those two statements are true, being that x is incremented by 1 and z is incremented by 1, both starting at 0, which means we should get 100 loops of this while loop. So this should run 100 times. So basically I want to say, let's do something really weird. Let's just say, put out a bunch of 8s. Okay, I'm going to fill the screen with 8s. 100 times. So while these two conditions are true, and we have an increment in here, we're going to print this out. So this should run from 0 to 100 times. So as you can see, we ran 100 times, but there is a simpler way of doing this. So the while statement, again, we can use two parameters, we can use one. So I can use, while z is less than or equal to, I don't even need x. So while z is less than or equal to 100, it's at 1, or it's incremented by 1, starts at 0, we just have z, it runs 100 times. So basically it's saying that you can set the number of times that the program or this loop will run this code inside of here. So I could have, anything inside of here, it will run this specific amount of times. But if we want to add more conditions, like say while z is less than or equal to 100, or and and x is equal to 4, and then we can just create an integer x and make it equal to 4, and it's always going to be equal to 4 if we don't create an incrementer for it. Then it's just going to keep printing out stuff. So since this became false, obviously it didn't work, but it didn't work as in a recurring loop where it kept going forever. But if I was to make that, while z is equal to 100, change its value to 100, take away its incrementer, then just see out 8, forever until, the end of time. It'll just keep spitting this out. You don't want to run this though, because sometimes your computer will crash, or not your computer, but CodeBlocks will. Some computers actually could probably crash from it if it's not powerful enough, but that's something that you don't want to do. So you always want the while loop to end. You don't want to set it to something that's never going to end. So I suggest you run your program, a specific amount of times that you need it to be ran. Other than that, you shouldn't be running it forever, because there's not many times in programming where you're just going to keep doing the same task no matter what. There's always going to be some condition, some factors that come into play that explain that variable, and explain how many times that variable needs to be displayed, or how many times that variable needs to come up. So you don't really want to create something that's going to be an infinite loop unless it's necessary. So realize that to get these to stop, you need incrementers. If you don't know what an incrementer is, go back to the for loops video, watch that over again. I explained a lot about incrementing. But other than that, that's how you create a basic while loop. It's very simple. It's just as simple as the if statement, just as easy as the if statement, and basically the parameters are the same because you're passing through conditions that can be true or false, and if true or false, based on an arithmetic operator, you'll get a certain output, or you won't get a certain output. So if you need any help, please leave me a question, and concerns below. Other than that, I'll see you guys in the next tutorial, and see you next time. Welcome to the TechSpace, and in this video we're going to be going over how to actually see the memory addresses of your variables that you create. So as we went over earlier, you can create variables, and obviously you know that by now, hope you do at least. You create variables and they're saved somewhere. So we have an integer x and it's saved somewhere. So it saves on the computer. So when I see out x, of course we know we can give x, the value of 5, and then x is 5. But what if we want to know where that's actually being stored on the computer for some specific reason? What we're going to want to do is go to where we see out, and right before we do, or we call that variable, we're just going to put the and sign, the ampersand, I believe it's called. So the ampersand x, and then we're going to build and run, and it's going to give us this weird combination. So this is basically the memory address of x. So we took x, we created the variable x, we gave it the value 5, and now we just want to see what that memory address is and where it's stored. So what we're going to do now that you can see sort of, what a memory address is, what it looks like, it's not supposed to really make any sense right now, but as you get into programming and software engineering and higher level stuff, you'll really need memory addresses because they'll be useful in certain situations. So what we're going to do is say, we'll leave this here, I guess. Okay, so we have integer x equal to 5, and then we're just going to say integer z, but not integer actually, we'll do double. So I'm going to show you the difference. So we're not going to set these to any specific values. We're just going to leave these blank, and that's all. So we have a string u. Another thing is when using strings, it's always cool, or it's always something that you want to do is add this header file to just include string. If you're going to be working with a lot of string variables and using them a lot, then you're going to want to add this. You don't really have to, again, unless something goes wrong. So like if I went to run a string and it said, down in my build that something was wrong, I might assume that this is something that maybe I needed to add up here, but again, keeping it there always helps. So we have now 3 variables, and I want to know the memory address of each variable. So what I'm going to do is I'm going to say, okay, we have x, I want the memory address of x, but I want that labeled as memory address of x, so that we can see this work. So memory address x, and we'll just say integer x, then we'll say double z, and then we'll say of string u, and we're going to get these values back. So as you'll see, we're going to change this. This is x, this is z, this is u, and again we're just taking the memory addresses of these 3 variables and we're printing them out on the screen. So as we see here, we have just a combination of some goofy text on the screen, but it's all different. So as you can see, it's 0 times 28 FEFC, FEF0, and FEEC. So that's how you find a memory address using C++. Use the ampersand symbol. Remember that each variable is going to be stored at a different memory address. If I keep doing this over and over, it's going to give me a different memory address for each variable, and that's basically it. So thank you guys for watching. If this video helped you, please subscribe, give it a thumbs up. I will see you in the next tutorial, and we'll be going over pointers, but if not, excuse me, it'll be in one of the tutorials coming up, and pointers actually cover how to directly access this memory address by creating a variable that actually points to a memory address. So we'll go over that later on. Again, it's not very important right now, but later on it will be. Just make sure that you understand how to locate memory addresses and how to figure out the memory address of a variable. And I'll see you in the next tutorial. Welcome to the Tech Space. In this tutorial, we're going to be going over the do-while loop. So just like the while loop, this is just a basic. It's just like the while loop, but we're going to be running this set of instructions basically before the loop is called into the actual function. So what we're going to do is actually, I'm going to go up here. We're going to create a new function because I just want to do that so that you get used to actually, creating new functions. So we're going to create loop 1, no parameters, and basically loop 1, of course, remember, if it's written below main, so if it's written below main and it's a function, then you need to prototype it. And I suggest keeping your prototypes tagged so you know where they are, it's always good to use comments where they're needed. So we have this void loop 1, and basically this is just going to be a function, and I'm going to call it into main. It's going to be the only function that we're going to call into main, and it's just going to be a do-while loop. So basically what a do-while loop is says, do this set of instructions while this is true. So basically, while, just as we did before, integer x is equal to 0, x is less than or equal to 100, and we're just going to say that x is less than or equal to 100 until it isn't. So until this is 101, this is going to keep running. So when we run this, we get a error. So we have while x is equal to 0. Let's see. So in function void loop. Okay, so basically we're not going to declare. Okay, so we don't want to declare the variable inside of while. So we're going to declare the variable outside of while. So we have integer x that's equal to 0. And basically while, I forgot, well, I didn't really forget, but I just messed up. While is a condition tester. So what it does is test conditions. So inside of here, we're not doing any type of testing. We're just doing conditions. So if the conditions are true, then it will actually run the code more. So like, as the for loop, when we take this, it runs this thing, and it's guaranteed to at least run this piece of code once. Why? Because this condition has to be true at least once, or it's not going to run it all. So if it's true, it has to be true at least once. So it's going to run this once. Now, we're going to delete this. Skip the for loop for now. We're doing do while. So what the do while loop does is it's automatically going to say that x is less than or equal to 100, regardless if x is equal to or less than 100 at least once. So what it does is it runs this piece of code, and then it says, okay, now let's do the while, and if this condition is true, we'll just keep running this till it's false. But again, we need an incrementer. But what we're missing here is that this value has to be conditional. So while x is less than or equal to 100 works, we can also use, and x is less than or y is less than 100, and then we can just create a variable y and set that equal to 0, then give that an increment. But again, we don't want to do this. We don't want to put any statement that declares a variable in here, and we don't want to put anything that's an incrementer in here either. So when we're incrementing, what we want to do is just put our increments where they should be. So x plus plus is in the do, and so is y plus plus. So we're going to run this again, and actually got an error, unexpected. Okay, so I'm sorry about that. So you just have to add the semicolon after while and press run, and there we go. So x is less than 100. It ran that as long as both of these conditions were true. The incrementers were inside the do loop, or the do set of instructions. Make sure that while is directly after this curly bracket that ends the do instruction list, and while is only a set of conditions that you do not try declaring variables as you would in a for loop. So that's basically what the do while loop does, is it guarantees that you're getting this code at least once. But if all else fails, it will stop running after that one time. Where for the for loop, it had to be a true at least one time for the loop to run. So this doesn't have to be true at all. It can be completely false, because while the compiler is reading it, saying do this, okay, after you've done that, then check this. It's not saying check this and then run this according to how many times this is true. It's saying do this regardless if this is true, then check if this is true and run it as many times as it says inside of the condition in here. So if you have any problems comprehending what's going on, please leave me a comment. I know it can be sort of hard to comprehend, but again, once you do it over and over, if you watch this video a few times, or if you need to just take a second on your own, write this down, write it down on a piece of paper, go over it, and figure it out. It's pretty simple, because it's just like the other loops that we've been creating in the past, and it works just like that too. So again, this is how you create the do while loop. If you have any questions, post them below, and as always, I'll see you next time. Welcome to the Tech Space, and in this video we're going to be going over classes and how to create them and what their uses are. So basically a class in C++ or in any programming language is used to hold function. So when we go ahead and create our stuff, so basically, when we create a class, we're going to want to declare it outside of main, obviously. You can put it inside main if you want, but usually classes are made outside of main. And basically, what we're saying by class is, like I said, we just want to have a class of functions, or maybe a class of similar functions that do, a certain goal, achieve a certain goal, or, all have similar traits to them. So basically, to do that, we want to type class and then a class name. So we're just going to put whatever, just put function class, and then you don't want to put parameters. Classes don't take parameters, so you just put braces and a semicolon, and that's the end of it. So next, inside here, like I said, you just create your function. So as you know, we can have functions with parameters, without parameters, and then I can just take some input, and then output it back to the screen. So like this. So basically we have a function, and it's inside a class, and to call it into main, what you're going to want to do is create an object. So what an object is something that you create that represents a class that can call the functions inside that class. And to get the functions inside that class, you're going to need an object every single time. So you need an object for the class inside main. And to do that, we're going to put function, or actually function class, like I said, the name of the function, or the name of the class, and then after that we're going to put just any name we want. So this is the name of the object, so we're going to put function object, and then a semicolon. There's no parameters to an object. An object, again, is just basically a pointer to this class. So anything inside the class I can use if I have this object. So now with that object, function object, we're going to call function 1. And to call it, we're going to use a dot. A dot, and then as you can see, function 1 popped up. It's the only function inside the class right now. So it didn't go. So function 1, and then just a semicolon and empty parameters, because there's no parameters in this class, just a simple input output. So then we can run it. There's an error. So one, I don't have a variable for C. It's empty, so we have a variable for C now. And then 2, there's actually one more thing about classes I didn't explain. So basically in a class, you can have public, private, and protected. And I'll go ahead and type those real quick so you know how they look. Protected, and then private. And basically, public, we're going to use now. Protected and private, you really don't need to know until, you're creating multiple files with different classes in them. So once you start doing that, you'll need private and protected. If you want to know what they are, you can go fast forward to the video that I explained them. But basically, for now, we're not going to be using protected or private. So public has to be in the class. So the reason public has to be in here is basically what it's saying is that we can have access to everything below this. So when I was to use private, or if I wanted to use private, I would just put that below here, and then everything below private in this class would be a private function, variable, or whatever's under here would be considered private and only specific to this class. So saying this is public means that we can use this outside of this class by using this object. So you're going to want to put public almost every single time. Again, every single time that you create a class until you learn what protected and private are. So just keep that in mind. Always add public, and then use the colon, and then enter your functions or whatever you have in your class below that. So that's basically all I need to say about public for now, and private and protected. And we have our object, we have our class, we have our function, and we can go ahead and run this. So basically it's just going to take in an integer C, and then spit it back out on the screen. Easy. Just wanted to show you what classes are. Basically, you just create the class, make sure you use public, create all your functions. If you have multiple functions, again, you could have different functions in here, and then you just call them using the same method. So say I had function 1, 2, and 3, and they all used, different integer values, of course. Actually, I could have kept that as C. So basically, we have, oh wait, no, at the top is C. Okay, so D. So say you have multiple functions in here. Basically what you're going to want to do is when you have the multiple functions in here, you can call them with the same object. So again, you create one object per class. You don't have to create an object per function, just per class. So if I was to have a whole nother class, then I would have to create another object for that class, specific to that class. So when I go back up here, or back down here to my main, and I call function 1, it's going to take function 1 again. But if I was to call function 2, then if I go up here, function 2, then it would take function 2 and I would enter integer b, and it would take integer b and show it back to me. So I could call all three functions, for example, which I'll show you really fast. So we have function 1, 2, 3, and then we're using the same object to call these three functions that are in the same class. So when we go and run this, we get the first thing, which, oops, clicked out of it. So the first one that it ran, we go here, down here in our main, was C. So function 1 was C, function 2 was B, function 3 was D. So we just enter, an integer 4, C is equal to 4. Click enter, go to the next one, enter 3, B is equal to 3. And then we should enter D now, so 9, D is equal to 9, and then it's open. So click enter, you're out of that. And then basically that's all you do. So again, you create an object, you can use that object to call the functions in that class by using this dot separator. Don't forget to put the dot separator and add the public to your class, because that's needed to use the functions in that class outside of that class. So that's basically all. If you have any questions, post them in the comment section below. I'll see you in the next tutorial. Welcome to TechSpace. In the last tutorial, we talked about classes. This is tutorial 18, and we're going to talk about constructors. So basically, what we learned in the last tutorial is that you can make a class that holds functions, and to use those functions, we have to use public so that our main function and other functions know that this information is in this function, or in this class. And then to use the class, or any function in the class, we have to create an object. So the object's still here for this class. Our public's still here, and we're going to create a constructor. So before we create one, I want to explain what a constructor is. So basically, it's just like a function. It's just when you call a constructor, it automatically is the first thing that will be called into the program. So whatever program you're building, a constructor will hold all of the information that then is executed first when you have an object of that class called. So down here, as you can see, I have the object declared already. So when I call when I make a constructor, as I'll make one. So okay, we'll go over making a constructor because it's sort of complicated. So inside a class, you make a constructor by entering the class name, and then enter parameters, and then braces. So basically that's all you do. This is a constructor. Later on, or actually we can do this in one video. So basically this is the constructor. It's just basically the class name in the form of a function. As parameters, you can put parameters in there, and of course the body. Then we have something called a deconstructor, and it's the opposite of the constructor. And to do that, we use the tilde, which is next to the 1, to the left of the 1 on the keypad usually, or on your mouse pad. And it looks like this. and then we just write the function or the class name, parameters, and then of course the body again. So this is the deconstructor. So everything in here is going to run after everything else in this class is done. So without creating a without calling any function, because these aren't functions, they're called obviously, like I said, the constructor and the deconstructor. So when you call the object, both of these are automatically called. This one will be called first, and this one will be called last. So no matter what's in between here, or even if you were to create a function above here, your function, class, or your constructor would still run before this function. So what you usually do, or what I usually do, is just keep the constructor up here, keep the deconstructor at the bottom, and that way you know the function or the constructor is going to run first, the deconstructor is going to run last. And again, the tilde is to the left of 1 on your keyboard, easy to find. You just click shift and that button, and that's how you denote the deconstructor. So that's how you do a constructor and a deconstructor. And just to show you, we can have just hello, and then just put this is a deconstructor. So without creating any declaration to call a function, we don't have to. We just have the object. As soon as the object's created, the constructor and the deconstructor will automatically run. And to show you, we can do this and build and run the program. And there you go. So hello, and this is a deconstructor printed out on the screen. And as you can see, the constructor ran first and the deconstructor ran second. So that's how you make a constructor, that's how you make a deconstructor, and that's how you use them in classes. And by the way, they're only useful in classes. That's actually the only place you can use them. Later on, when we have separate classes, again, you'll do the same thing. You'll just make the constructor and deconstructor, and we'll go over something called prototyping with that. It's just like regular function prototyping, it's just a little bit different. So we'll go over that later, but until then, thank you guys for watching. If you have any questions, post them in the comments below, and I will try to answer your question. Other than that, I'll see you next time.
Welcome to tutorial 19, and in this tutorial we're going to be going over switches and what a switch is in C++. So basically what a switch is instead of using if statements, like a bunch of if statements to test conditions, what we can do is use a switch. And the switch tests one condition, and it has multiple cases in it. So you could have, well, we'll go ahead and start it. So we have, let's create a variable, and let's just give it a global scope. We're just going to create an integer x and set it equal to 5. So in this switch statement, we're going to write switch, and then after that we're going to write parameters and then a body. Now inside the switch statement, what we have is parameters, of course, and that parameter is going to be tested. So sort of like an if statement, if you had a bunch of them, you would have, they test different conditions or the same condition for a bunch of different results. So if this happens, then this, and if this happens, then this. Basically what a switch does is it takes this condition, x, we could say, and we give cases. So switch x means that basically we're testing a condition of x, and inside here we're going to have cases. So case, and then we're going to say case of 1, which basically means if x is equal to 1, then output some bit of code. So, I could write a function in here, anything. And then after that bit of code, you want to write break, and then with a semicolon. And what that shows is that after this case, so fx was equal to 1. After case 1, and we get this output, it's going to break. And then we can add another case, so in case of 2. So in case integer x is equal to 2. So in this case, we'll have x equal to nothing, and then we'll just say something like enter a number and then store it into the x variable. So it says enter a number, and then we just want to give the user somewhere to input that number to, and that's going to be x. So the user is going to enter a number, it's going to be stored in x, and the switch condition or the switch statement is just going to test x for these cases. So in case of 1, cout, you are number 1. And then we could, just end that. We don't really need to end the line. And then in case of 2, we can just say, you are number 2. And then don't forget to add a break. And we'll do one more. So case of 3, cout, you are number 3. Then we're going to add this last break. And after all of this, what we're going to want to do is add a default. So in case the user doesn't enter 1, 2, or 3, we have to have a default statement that prints out in case they enter, again, something that is not in one of these cases. And again, you could use a string for this, but we're just using integers. So cout default, we're just going to say you picked an invalid number. And then again, for default, you do not break actually. Yeah, I was thinking of JavaScript, and JavaScript use breaks, but in this you don't. In C++ you don't. So basically, this is our switch statement. We have switch. It's just inside int main, and it basically just tests the number that the user inputs. And if the user inputs 1, 2, or 3, it outputs some text on the screen for whatever number they enter. And if they don't enter 1, 2, or 3, it's gonna say you said or you picked an invalid number. So we'll go ahead and run this. And it says enter a number. I'm enter 1. It should say you are number 1. Okay, got that. Then run it again. Number 2, you are number 2. And last 3, you are number 3. And then again, if you enter a number that's not 1, 2, 3, or 1, 2, or 3, say I entered 4 or 5, let's just say 4, then you picked an invalid number. And if I wanted, send that line to make it look a little cleaner when we run the program, you get this press any key to continue on a separate line, so it's just a little clearer to see. So I picked 4, and I picked an invalid number because it was not in the case in here. So if I go before default and say, okay, in case of 4, cout, you picked 4, or let's just say you are number 4, just like the rest of them, you are number 4, then when I go to run this again, if I enter 4 this time, I'll get you are number 4 because it was written in one of these cases. And that's basically how you use a switch statement. All of switch statements, again, one last thing I want to mention is that you can only use switch statements if the cases are integers. So if it isn't an integer, then you cannot use it as a, in terms of numbers, you cannot use it in a switch statement. Like I couldn't have in case of 0.5, just because that's not how a switch statement works. We have other things for that, just like the if statement, the else if statement, and other things to test conditions. That's why we don't use doubles or floats inside of our switch parameter. So when you do make your parameter, make sure it's an integer, make sure your cases are all set to integer values, And that's basically it. So thank you guys for watching. If you have any questions, post them in the comment section below, and I will see you in the next video, which I believe is tutorial 20, and that is on the size of command, and we'll learn all about that in the next video. So thank you guys for watching. Have a great day.
Welcome to the 20th C++ tutorial on the text space, and in this tutorial we're going over the size of commands. So basically, I don't know if I should have made this one tutorial, maybe I should have just put it in a different tutorial, but basically size of is just a command, just like this, and it has, of course, parentheses, parameter, marks, and basically you write something in here. So that's how you use it. Let's use it. So let's create a variable called x and a variable called y, and we'll set y equal to something, and we'll set x equal to nothing. Then we'll create a double x2 and then a double y2 and set y2 equal to 100 as well, just as a different variable type. So now what we're going to do is use the size of, and I'm going to show you how it works. So basically, it works like this, and let's make a few of these really fast. So we'll make, we need 4 of them. We're going to output the size of each variable. So you're thinking, okay, x doesn't have a size to it. Yeah, it does. So before we went over variables, we went over how they are stored, how you create a variable basically to store information in it. So you create a variable so that you can take information and then store that information in that variable. And depending on the type of variable it is depending on the type of information that you can put inside that variable, and that you can also give that variable any name that you want. So we have an integer x, and if you don't understand that, you can again go back to that video, but everybody should understand that by now, that if you have an integer x, it's not set to nothing, that it's still a storage space called x. So some integer is going to be stored at x. So basically we're going to get the size of x, and we'll do this. Size of x, and we're going to use the size of command to use or get out the size of x. So when we get the size of x, it'll show us the size in bytes. So since there's no value to it, it'll show us the size in bytes. And we'll see what happens when we use y to get that size, even though it does have a value. So as you can see, y is equal to 100. So when we go size of y, we'll see what happens. So then we have x2 and y2. So size of x2, go back, size of y2. And then we'll go ahead and run this really fast. So as you can see, we got size of x is 4, size of y is 4, size of x2 is 8, size of y2 is 8. And that's because that's how many bytes. My particular computer, yours might be a little bit different depending if it's a little bit, I think it goes by hard disk, how much memory is on there. I'm not sure. It really doesn't matter. It just means that the size of x is 4 bytes because it is an integer. So integers are stored in 4 bytes, and doubles are stored in 8 bytes, as you can see. So since this is stored in 8 bytes, even though it has the value of 100, and even though this has the value of 100, it's still size of gives us the size of that variable in bytes. So that's what the size of command does. If you have any questions, please post them in the comment section below. If you have any, and as always, Thank you guys for watching, and I'll see you in the next tutorial where we're going to talk about constant variables and constant functions. Welcome to TechSpace, and this is tutorial 21 of C++, and in this tutorial we're going over constant variables and constant functions. So basically we're going to learn how to use constant functions and constant variables. So before we do that, we need to know what a constant is. And basically, just like in anything, a constant is something that doesn't change. So it's something that stays the same throughout the program. So you don't want to create a variable. So for instance, actually we'll go over this. So if I have an integer called x, and I set it to 10, and later on in the program I have, let's just say later on in the program, I want to change x for some reason. I want to change x to 20. So instead of x being 10, I want x to be 20. So when I see out x down here, x will be 20. And when I see out x up here, x will be 10. Because remember, this compiles from the top to the bottom. So when we run this program, since this is in the main function, we'll get 10 right here and 20 right here. We already know that. So 10, 20 in the program. So when we did that, we changed x to 20. So if we had this as a constant, to do that we do const, constant, without the a-n-t. So it's just const, space, the variable, and then the variable name, and then whatever it's equal to, or if it's not equal to anything, just a semicolon. But in this case, we had it equal to 10. So if we have a constant, x equals to 10, and then we go to change it, it's not going to work because this is a constant. So we're saying we have this integer that we never want to change in the program. So when we go to create this, it's going to say, okay, you could declare x as a constant, but x down here says that you want to change it to 20, which you can't because it's a constant. So when I remove the constant, it works. But when I put the constant back, it doesn't work. And that's simply because you're not allowed to change the contents of x when it is a constant. So the same thing with a function. As you can see, when I print this out, x is 10 both times because it's constantly x. So the same thing with a function. We'll go ahead and delete this stuff. I'm going to create a function, and we'll do it down here. And it's just going to be called, I'll make a prototype really quick. It's going to be a constant function. It's going to be an integer, we'll make a string function. It's just going to return a name to us, and that it's just going to be called name function. So we have a constant string function that has a name function with a parameter, let's say, of y. So then we're going to go down here below our main, and remember in here we're going to want to call our function eventually. So we're going to eventually call the function, but we're going to create our function. So we're going to say constant string name function string of y, and add the body. And then we're just going to say return name. And then instead of y, actually, right down there I wrote name. Since we're using a name function, we're just using this to get a name, we're just going to use this as a string, and we're going to say get name. And again, we don't want to use void in this case because a void function does not have a return type. A return type is the ultimate goal, or the ending to your function. So if I had a bunch of stuff up here besides that, like integer x is equal to 9, and then I set, integer y equal to 10 or 20, whatever, and then I see out x plus y in the line, that's cool, but if I have a return, and it's just going to return the name, the return type is the ultimate goal of this program. So this could be some code that's in this function, but the ultimate goal of this function was to rerun this parameter. So without using that parameter of the function, it's not going to run this program because it's saying the return type of this function, my bad, is name. So that parameter is specified in this function before it's written. So just to make sure that you guys know, the return type is the ultimate goal of that function. So we have a constant string function with the name. We have a prototype and it's returning the name. So when we go up here in int main and we say we want to call this function, so what we're going to do is just type name function, and then in here when we're calling the function, remember we have a string parameter that we have to add. So in here we'll just type the text space, and that's the end of it. So when it sees this, it's going to set that parameter name automatically to this right here. So we could have specified, name somewhere else. We could have specified name somewhere else. I could have created it up here and just gave it the value of the text space, But instead of doing that, we use the parameter name in a constant function and then called that and gave it the value up here when we called it. So as you see, when we call the function, we don't have to declare it as a constant because it's already prototyped as a constant. So when it runs through int main, it's saying, okay, I know this prototype, and I know this function is going to be somewhere within the program, and it's down here, and I know that function, all that I want to do in that function is return the name. And I don't have the name yet, but if I look up here, name function has a parameter, and the parameter is a string, so we're going to set that string automatically to name. So if I would have had two parameters, so if I would have had name and then another string called y, and then I went down here and added that as well, string y, and then we'll say return name plus y, and then I put parentheses and then welcome. Then, so that's how you use constant functions, constant prototypes, and then call the function using a parameter. So the parameter was sort of just something extra. I have a different course that I'm going to do on actual practice problems for C++, helping you build your skills with C++ and other programming languages. So you can check out those if you want practice problems for in between these videos, and they will be in order from hardest to, or from easiest to hardest. So they'll be in line with the videos, and they'll be using similar things that you've learned to actually apply them to real-world applications and software and logic and stuff like that. So if you want to watch those, I highly suggest that you watch that series and subscribe to my channel. The next video we'll be doing on C++ is inheritance, which has to do with classes. So stay tuned. That is tutorial 22, and I'll see you there. Welcome back, and this is C++ headers, and we're going to be going over headers. So basically, we'll get rid of all this stuff from the tutorial. What headers are, these things right here at the top. And what we need them for are to reference different types of code. So throughout, going through C++, you'll run into different types of header files that are used for different things. For one, they're used to create different classes. So when you have more than one class or more than one file, you can store different classes in different files. So instead of saying class and making the class in this file, you can actually make a different file on how with a class in it. So I'll make a video on that later on, but for now, that's basically what it is. So when you're using a header, you're just referencing to something that is either a class or just basically a library of code or something that allows you to use code. And basically the best place to use it, or I mean not to use it, but to go, is C++ leaf.org. Let me pull it up here. So here's the website. I got to the library part. If you go to c++.com, you go down to reference and C library. You can see all the headers right here, and if you click on them, it'll show you what they are. CMath, for example, is used when you're using these functions right here. So, for example, exponential functions, exp, if you're raising to the power, POW, POW, SQRT for square root, CBRT for cube root, and all these different types of functions that you can use. You have to use the CMath include file, which is done just like this. Include CMath, and then just as it said in the website, so we can try to use square root, we'll just say cout SQRT like it said, and then just say 16. And we should get 4 back in the program, and we can see we got 4. So that's just an example of what a header file is. And again, you can go to the c++.com to reference all of the different libraries and different functions that you can use, such as square root and power, POW, and then stuff like that. What else was there? CBRT for cube root. So basically, you can reference different types of functions like this using different header files, and there's tons of different header files in C++ that you can learn about by going to c++.com. I'll put the link in the description to the page that I was just on, and I'll also put a link to the page of the original c++.com website. But thank you for watching, and I'll see you in the next tutorial. Welcome back, and in this video, this is the 22nd video, and it's on inheritance. And basically in this video we're going to go over inheritance and what it is and how to do it. So what we're going to do first is create 2 classes. So from the previous videos, you know how to create a class. Just create 2 classes. So I'm just going to name this class 1 and create another class called class 2. You can name yours whatever, but that's what I'm going to name it. So basically what inheritance is say I have functions in this class, and just create a few functions in your class. So void function 1, and then say we just have another one, function 2, and they have no parameters, just very simple, just to show you an example. So create 2 classes, and then create 2 functions within each class. And actually just for 1 class. So just create 2 functions in the first class. So basically what we're going to do for inheritance is basically for this class, oh, forgot to add the public. So for this class we have 2 functions, function 1 and function 2. And they will just simply print out I'm function 1 and I'm function 2. And we have a class number 2, and this has nothing in it. So what we're going to do is create an object for class 1 and just say class 1 object. Again, you can name yours whatever you want. I actually encourage that you change the name of these so that sort of, tests a little bit more, so you're not just going through it. You can just go through it, it's just preference, but basically we have two classes and we're going to go over inheritance. So class 2 can't really use function 2. So if I go to use function 2, it's not going to pop up, as you can see, and it's not going to allow me to use it. So when I create class 2 object, and I go down here and I want to use my class 2 object to call function 2, it's not going to work. And the reason that it's not going to work is because function 2, even though it's public and it's in class 1, for class 2 doesn't have function 2. And it's not, it doesn't know anything about class 1. They're different classes. So if you're building a program and you have, say you're building a game and you have all your guns in this class and all your cars in this class, all of your cars have nothing to do with all of your guns. So that's why you create different classes. You create similar functions that have similar attributes that, are different from one another. So other than that, you wouldn't need to create a class. So the reason to have different classes is to have different similar things within those classes. But to allow one class to use the other class, so say if I had a car that had, and we'll go ahead and I'll change this. So we have class car, and we'll change this down here, and then we have a class guns. So class guns, and then there's just function 1 and 2. Cars lowercase down there, so cars lowercase up here, and guns matches that. So we just have these two. So say I had a car that used a gun, or let's change this around, sorry. Okay, so guns up here, car down there, guns, and then let's just say guns object, and then car object, and then guns object. So basically what we're doing is, okay, so when I went to call function 2 from the guns class, it didn't work. And the reason I changed this is, as it was a little bit complicated, you'll see why. So when I have inheritance, basically, let's just say I have a car. Let's delete this because it didn't work. I have a car that uses a gun. So I have a car with a gun on top of it or something, and for that reason, I don't want to rebuild the function that has all of the, instructions of what that gun does. So say if this was gun 1 and gun 2, then gun 1, say if I wanted to use in this car, I didn't want to rewrite this function down here. So say if I went to write, void gun 1, and then I had to rewrite all of those instructions, or I even had to, go up here and copy and paste it down here. Instead of doing that, I can access that class by using inheritance. And inheritance is used by going in between the name of the class and this first curly brace. And you put a colon, space, or you don't have to put the space, but I recommend doing it. Put public, space, and then what we put after that is the class, or not the class, but the class's name that we want to inherit from. So we type guns because in this case we want to inherit a function from guns. And when we do this, we're inheriting all the public functions. So again, later on we'll go over private inheritance, But for now, we just want public inheritance because these two functions are both public. So now that we have a public inheritance on this car class, we can now use our guns on this car. So that was just, metaphor. So basically what we're going to use is those functions in this class now. So what I can now do is say I do want to call function 1, and as you can see it does pop up as a recommendation by CodeBlocks. So I can use function 1 here. So let's just say I have a class car and I have a constructor, and remember constructors are the first thing that run when you call a program. So I have a constructor, or not when you call a program, but when you're calling a class and you declare an object. So the first thing that runs when you declare an object is the constructor. The last thing that runs when you declare an object is the deconstructor. And basically, this constructor, which is the first thing that's going to run when I call my object for the car class, is going to run function 1. And since we have an inheritance for the public, we have a public inheritance on the guns class, I can use function 1 in the car class. So the constructor runs function 1, and that's basically all it does. So now that I have car created and I created an object for it, I have a constructor, I can go ahead and run this program. And as you can see, I get an error, and for that reason is that everything in here isn't set to public. And that's it. So should be able to run it now. There we go. So as you can see, I am function 1, and that's because the car class inherited function 1 and ran it in its constructor. So thank you guys for watching. If you have any questions, please put them in the comments below, and the next tutorial is going to be over headers, which are these things up here, which we'll be going over again in the next tutorial, tutorial 23. So I'll see you in the next tutorial. Thank you guys for watching, and I'll see you there.